Okay, like I told you guys, this is going to be a pretty quick video. I just wanted to make a quick video talking about the different, the best method, how to choose the best method. At this point, you've learned how to solve systems by graphing. You've learned how to solve systems by substitution and by elimination. So how do you choose the best method? It's not just simply by saying, okay, I prefer to do elimination, or I prefer substitution, or I prefer graphing. You can do that when you take a STAR test, but when you are doing a problem in class, because we have to learn all three ways to solve systems of equations, you need to figure out what the indicators are to determine what the best method is, okay? So for example, if we look at example number 1, we're looking at 2x plus 7y equals 3, and then x equals 1 minus 4y. If you look, what happens is that you're already set up pretty well for a particular method. Just take a second to see if you can figure out what particular method I'm talking about. Okay, you're set up already for a substitution problem. And the reason is you are already solved for a variable. You're already solved for x. You know what x is. You don't know the value for sure, but you do know what x is. So because I have x equals something, I'm set up for substitution already. Okay? So what I would do then is say, okay, I'm going to substitute this in here. Sorry, this in for x. So then I end up with 2 times 1 minus 4y. This is kind of a review of substitution. 1 minus 4y plus 7y equals 3. I can quickly plug this into that one and solve using substitution. I would distribute. I would have 2 minus 8y plus 7y equals 3. Combine my like terms, which happen to be right here. So then I would have 2 negative 8 plus 7 is minus y equals 3. Solve for y. I would subtract 2 from both sides. I would have negative y equals 1. Take that negative to the other side. I have y equals negative 1. Then of course go back in and plug it in. X equals 1 minus 4 times negative 1. X equals 1 plus 4. X equals 5. So my solution to this one would be negative 1. I'm sorry, out of order. My solution to this one would be 5, negative 1. But the biggest key I wanted to show you is this is a substitution problem because it is already set up with x equals something. Okay, it's important that you understand that and you look for that indicator. All right, let's take a look at example 2. Example 2, we will do 6x plus 2y equals negative 10 and 2x plus 2y equals negative 10. So here's our system of equations. And if we look at this one, they're both already in standard form. ax plus by equals c, ax plus by equals c. Since they're both in standard form, the best method for this one would be elimination. So a good rule of thumb is when they're both already in standard form, you can use elimination. All right, so let's just go ahead and solve this for some extra practice. If you look right here, I don't have anything that will cancel out. 6 plus 2 is 8, 2 plus 2 is 4. That doesn't cancel. I need something to cancel, so what I'm going to have to do is multiply by negative 1. So I'm going to multiply everything on the top by negative 1. This is going to give me negative 6x minus 2y equals positive 10. Negative times 6 is negative 6x. Negative times 2 is negative 2y. Negative times 10 is a positive 10. Just bring down the other one, and I end up with 2x plus 2y equals negative 10. If I work this out, negative 6x plus 2x is 4x. This cancels. I'm sorry, negative 4x. That cancels. Equals 10 minus 10 is 0. Solve for x. Divide both sides by negative 4. X equals 0. So then I go back in plug it into one of my equations. That bottom one looks easier to me, so I'm going to do 2 times 0 plus 2y equals negative 10. 2 times 0 just cancels out because 2 times 0 is 0. So now I have 2y equals negative 10. Divide both sides by 2. Y equals negative 5. So my solution for this one would be 0, comma, negative 5. Again, the key component here is that these are already set up in standard form. ax plus by equals c, ax plus by equals c. Even though nothing eliminates right away, it's still not that difficult to do that. So that's the key component to systems with elimination. Okay? Let's look at a third example. Okay, let's say your system was y equals 2x plus 3 and y equals 4x minus 1. It's pretty easy, in my opinion, to determine what type of system that, or I'm sorry, what form or what method I would use to solve that one. This is already in y equals mx plus b, y equals mx plus b, and because of that, I can just go ahead and graph those both very easily, especially when you learn the graphing calculator method. Just plug those two bad boys in the calculator, hit a couple button pushes, it's going to give you the answer. But even if you don't, it's already a y-intercept slope, and just graph it. We're not going to take the time to do that right now because it's just a little time consuming and I don't want to make this video short for you. But when you're already set up in y equals mx plus b, you want to graph to solve this one. When set up in y equals mx plus b, graph to solve these. All right, one last example I want to do. And partially because we didn't cover it in class because I didn't think our homework was going to have it in class. But I found out that our homework does have it, so I want to do one more example. We're going to do 9a minus 2b equals negative 8. Negative 7a plus 3b equals 12. Okay, here's our system of equations based on what I just talked about choosing the best method. What would be the best method to solve this one here? Well, it's in ax plus by equals c, ax plus by equals c. They're both already in standard form. Because of that, we're going to use the elimination method. Now this one's a little more tricky. Okay, and this is the one I didn't think we were going to have to do in class or on our homework side, but it turned out that we did. So watching this video is going to help you with your homework. I told you to look into class earlier and say, okay, can I turn 9 into 7? I cannot. Can I turn negative 7 into negative 9? I cannot. Can I turn negative 2 into a positive 3 or negative 3? No. Can I turn 3 into a positive 2? No. If I say no to all of those things, that means I'm going to have to multiply both equations in order to make this work. So what I would do is take the two equations that have a pair of numbers. 9 and 7 are a pair, 2 and 3 are a pair. Take the smallest pair. And then what I'm going to do is I'm going to multiply the top number by 3. That's this number here. Okay? I'm looking to cancel out these. I don't have to multiply by negative because this is already negative and this is already positive. So the signs are already different. So I can multiply only by a positive number. So I'm going to multiply that one by 3. And what that's going to give me is 3 times 9a is 27a. 3 times negative 2b is negative 6b. 3 times negative 8 is negative 24. Now, with this, if I just brought that down like we normally would, nothing would still cancel out. So I'm going to have to multiply the bottom also. I will multiply the bottom by this number here. That 2. I said find the smallest pair. Because see, I multiplied this number here and this number there. And again, they're both positive because I have a negative and a positive. If one of them, if they had the same signs, then I would have to multiply by a negative. Okay, but because they have different signs, I can multiply by a positive. So the second equation becomes 2 times negative 7 is negative 14a. 2 times 3 is positive 6b. 2 times 12 is a positive 24. Okay, when I work this out, 27 minus 14 is 7a. Okay, negative 6 plus 6 is canceled, equals negative 24 plus 24. It also cancels, leaving mu as 0. Divide both sides by 7. A equals 0. Now I go back to one of my original equations and I plug it in. So now, instead of 9a, I'm just going to use the top one because they're both equally difficult. Oh, actually, I'll use the bottom one because that seems easier. Negative 7 times, instead of a now, I'm going to put in 0. Negative 7 times 0 plus 3b equals 12. Negative 7 times 0, well, that just cancels because 7 times 0 is 0. That's nothing. So that gives me 3b equals 12. Divide both sides by 3. b equals 12 divided by 3 is 4. Again, alphabetical order. My ordered pair is going to be 0, 4. So hopefully, if you've started your homework before you watch the video, hopefully this clears up some frustration that you might have had. If you watched the video first, now you can do your homework with no problem. Again, I apologize for not going over an example like this in class. Hopefully this clears it up for you. All right, that should be it. Again, we have a quiz on Friday, so make sure you're getting yourself prepared for that. Again, D-Day is coming on Friday, so please don't forget your detentions if you have 2 or more zeros, so get that taken care of. All right, good luck. See you tomorrow.